Welcome to last session of this FDP. Today we have one more eminent speaker, come academician, Dr. Lakshmikanth. He completed BE in Civil Engineering from Anna University and MTech in Environmental Engineering from Anna University. He completed PhD and postdoc from IISc Bangalore in the area of geo-environmental. Currently is working as a senior scientist at CSIR 4P Bangalore. Before that, he was working as a scientist in CSIR NIRI in Water Technology and Management Division. His main interest includes greenhouse gas measurement, estimation and modeling, climate change and urban health risk, environmental forecasting, ocean modeling, waste management and disposal, contaminated science remediation, and circular economy, and climate and water. He has published more than 50 publications in peer-reviewed national and international journals, also conferences. He has published 5 book chapters, 2 technical articles. He has guided 1 PhD student and several masters and bachelors. He has executed several projects funded by the DST, DBT, CPCB, and other funding agency in the domain of environmental. With this introduction, I request Dr. Lakshmikanth to deliver a talk on landfill fires, causes, control, and mitigation. Now it's over to you.
Thank you, Dr. Naveen. Am I audible?
Yeah, it is audible. Please go ahead.
Okay. So, first of all, I would like to congratulate, I think the director, Dr. Debi Prasad Mishra, and Dr. Naveen, and whoever's been involved in this for choosing such a a topic like waste to wealth and waste, because these kind of topics are really the concern of the day today. And I think more and more that we work or gain knowledge in these areas, I think the future will be more sustainable and good. So with this thing, I'll take you through this topic, which is like landfill fires. Most of you might not have heard this as a major issue, but then if you look into the core aspect of this, which doesn't get surfaced as much as the problem is, or as much as big the problem is, this is really a big issue with respect to pollution, with respect to management, with respect to handling of waste. Because like we all know that we generate huge amount of municipal solid waste. The rate of generation in India is around 0.7 kgs per person. So if you estimate in India itself, it's more than several tons of waste, more than 45,000 50,000 tons of waste itself is generated per day per city, metro cities. So there have been several incidences of landfill fire. So this fire issue, it leads to a lot of pollution, even damaging the stability of the landfill, etc. So why I actually chose this topic when Dr. Naveen called me is that there has been a lot of research happening in the domain of waste to wealth. Plastic roads have been constructed. Fly ash has been used in some really useful things as eco-additives or other applications. Whereas this waste, it doesn't fall under any category. It is neither soil nor properly waste. It's they call it like earth-like material. On top of it, there is such kind of issues of environmental pollution and handling issues, etc. So this one issue, landfill fires, is a huge issue. So I thought, let us take you through this thing, and then how to mitigate that, control that. So for that, we have to really understand the causes of that. So landfill fire is a disaster or a hazard or an extreme event. I don't know what to call it, but it's definitely a problem. So if you see the risk of, yeah.
Yeah, sir, I'm from the technical team of NITER Kolkata.
Okay.
Sir, you please disable the annotation option in the slide share. In the top right corner, you can see annotation, and beside that, one more is seeing. You can see the more option.
Hide names of annotators? Is that the thing? Or
Yeah, in
disable
the,
annotation?
yes. Disable annotation.
Is it okay now?
Yes.
Okay, fine. Yeah. Thank you so
Thank you
much.
very much. Yes.
Thank you. Yeah. So of lately, what was perceived as a small problem now is falling into the category of a disaster, hazard, or extreme event because of the issues like climate change, the inability of our people to manage this efficiently. So if you take the definition of a climate or disaster risk, it's probability of likelihood that a hazard or a long-term change will cause some injury, damage, or loss. So if you see according to that, this definitely this kind of what to say area or fire, that landfill fire falls into this hazard category. So if you see the capacity of the community, if it is the capacity of the risk is very high, then it's definitely a big issue. Yeah. So, changing hazards and needs, as I said, the definition of hazards, the, characterization of hazards has, changed, significantly over a period of years. Uh, the hazards means the level of exposure or the level of risk is, very high. So in this case, also it is very high. One is it causes severe damage to the environment. There was a fire in Mumbai, the landfill, the smoke of which was captured by the satellites. That is still in the newspapers. And every now and then you can see, there was a huge fire in Bangalore, in Kerala. Of recently, there was a huge fire in Kerala. Then, of course, Delhi is always in news because of these issues. So, yeah, so we need to give some, technical feasible solutions that can resolve these issues. So, you can call it a disaster management or whatever it is. Sometimes they see it as a climate change or what to say, or anthropogenic activity. So I wouldn't go into this, but I'll directly take you to see. This is, you can see the pictures of these landfill fires that is happening. So one what to say, very dangerous thing is that once there is a fire in a landfill, it's very difficult to, because it just propagates along with the wind and then it just carries on. So you can see two examples. Both these landfills are in New Delhi, and it's a huge problem. It's like a little mountain close to 70 feet, 60, 70 feet high. So this is Ghazipur landfill and this is Palstar landfill. So also you can see newspaper clippings these are the newspaper clippings of this landfill fires. I mean, it's there in every state. So if you see the existing status of MSW landfilling, it's it's the ultimate disposal option in most of the developing cities or developing countries, and especially countries like Asian countries, where the technology is not that advanced as compared to the West, where they don't go in for landfilling, they go in for segregation or technical other things like thermal treatment. So if you see in India, around 70 to 90% of urban solid waste is being dumped into the landfills. There is a new rule. According to that rule, it's the MSW 2016 rules, which was the first one to come out, and then recently there's another rules. So as per that rules, it is said that no organic waste should directly go to the landfill. So there is a pre-treatment process that needs to be carried out. Like mostly in India, it is composting, and then after that, whatever combustibles are there, it can go into the RDF, and that RDF can be sent to industries like cement kilns or wherever this kind of boiler issues or boiler things are there. Those can be used there. So that is the law as per the as per the new rules. So in India, most of the landfills are non-scientific because they just found some dumping space and then they started putting the waste. This was like some time before, but now the concept of smart landfill, scientific landfill is coming up, but then it will take some time to really, get into action. So if you see, urban India generates around 62 million tons of waste annually, and it has been predicted that it will reach to 165, almost more than 3 times. So 43 million tons of municipal solid waste is collected annually, out of which only 31 percentage, only 11%, 11 million is treated, and the rest, almost 30, is landfill. So landfill ranks as the third major source of anthropogenic methane emission, GHG emission. If you take that in India, it is around 7%. So methane is having around 28 times more global warming potential than carbon dioxide. This waste bio that we are talking about, that is like derived from the biomining. Biomining is nothing but removing the existing waste that is piled up in the waste dumps, and then what to say, making it into some kind of useful what to say material. That material is called a bio. So what happens is they'll remove that material, they'll make it pass through several sized trommels. Trommels are nothing but big filters or big sieves, and then once the size is reduced, then it can be used in some form. That is the whole idea. So that they call it as the waste bio earth. And then the thing is, like, when they are doing it, it's really toxic due to high heavy metal concentrations and several other side effects. It's not suitable to use as fertilizers. Only the waste that is like say passing through 4 that can go into compost. But then there are, for that also you need to do several kind of tests, like whether heavy metals are there or not, the nutrient content, NPK content, all those things comes into picture. So the thing is, like, biomining practices are leading to toxic, what to say, waste bioearth accumulation in several of these plants. So also these biomining plants are lacking the alternative disposal techniques of waste to bioearth. So the urgent need here is the cost-effective technology to utilize this bioearth in some form, and also to mitigate this landfill methane emissions because of its severity. So if you see the causes of landfill fires, one is like improper segregation of waste, because usually what happens in India is the segregation is not what to say up to the mark. It goes into landfill as a mixed waste, where it is being composted and several other things happen. But then if it is segregated at the source, as they say, then it is really effective, and these kind of issues may not be happening there. Then some of the most common things are like you usually find the rag pickers or people who collect the big chunks of the waste that is like of some economic value, and then they sell it off. So those people who are doing the scavenging activities, they usually, what they do is like they smoke, or they somehow lit a fire there, which causes this this is all what is a man-made kind of thing. Then one of the most things that is commonly seen is the absence of fire management systems. If there is any fire, they'll either dump the C&D waste, or call for the fire engine, or just what to say, put the leachate there. Then it also depends on the site characteristics and climatic conditions, because India is a tropical country mostly. Then through our studies, what we have seen is the temperature at the surface even reaches close to 90, 95 during the peak summer. There is some talking about places like Nagpur, Delhi, where it's like really, really, the humidity is very, very less, like less than 10%, and then the temperature is like close to 45, 48, 50, the ambient temperature. Then the biological and chemical degradation, of course, because of the, what to say, aerobic and anaerobic degradations, there is always a what to say, heat release, which causes the temperature rise. Both are exothermic reactions, and along with that, oxidation reactions. If there is any, people dispose this batteries or some kind of metals, which also causes oxidation, and further it leads to energy generation or release. So this heat, whatever is generated there, gets, I mean, like, plays a vital role in rising the temperature of the waste. And then there is this, what to say, fire. When it comes to fire, there are two types of thing that really matters. Is that what to say? There is one as a natural thing, and one there is a as a non-natural thing or a man-made thing. So we'll just go into the details. So what happens, if you see, what happens is, like, there is waste, and there is some degradation happening, as I said, like the anaerobic or aerobic. So it's like it's a mixture of fresh waste, old waste, and partially degraded waste. So what happens here is there is a rain, it percolates and comes out as leachate. This also pollutes the what to say, nearby groundwater bodies or surface water bodies along with the soil. And then this biodegradation reaction, what happens is there is a heat generation, because of which there is a temperature rise, and and because of this temperature rise, there is a formation of what is called as a fire triangle. The fire triangle is nothing but the sources, like the required parameters for a fire that is there is is available or is made available. So the required heat is given by this reaction. The fuel is nothing but the waste and the methane that comes out. And of course, for any fire to happen, there needs to be oxygen, some concentration or some. So that is all there because it's on the surface, and then the air has plenty of oxygen. So what happens when this thing happens? There are two processes that occur. One is like waste smoldering, and the other one is waste ignition. So waste smoldering is nothing but, I can say, or you can define that as a change in the physical form. As the temperature rises, you would have seen that, slowly the waste component, or say for example paper, when it starts burning, or just before it starts burning, it just shrinks in size, and then only it catches fire, something like that. This happens to most of the materials. So the thing here is like, if it stops at smoldering, then it is not an issue, but then this continues, and then this uh, continues to ignite the waste. So when the smoldering continues, it actually leads to waste ignition. And when there are these two processes, this gives out high carbon monoxide along with CO2 and say other gases like NOx and all those things. And then also it raises the surface temperature. All this contributes to your environmental pollution. So this is just a list of landfill fires that was reported from the year 12 to 20. So you can see, the what is the number one, number two. You can see a lot of what to say, landfills, and you can see that it's not just concentrated in one place. It's like across India. So starting from Delhi, Mumbai, Pune, Nagpur, Jaipur, Gurugram, even South Coimbatore, Bangalore, right? Pondicherry, Bhopal, so Hyderabad. So it's like quite evenly distributed. It's not that this thing is not happening. It's happening, but then we are not that maybe say we can say concerned about these things. So what are the challenges in managing this landfill fires? So one thing is like the spontaneous subsurface fires are the most intensive ones. So I forgot to tell you that there are when you take the fires, there are two kind of fires that come into picture. One is the what to say surface fires that happens at the surface or just below the surface, and then the other one is the so say subsurface fires, that is deep within the landfill. At least below a depth of say several meters, below a depth of 5 meters. So if you see the spontaneous subsurface fires uh, are the most intensive ones and hazardous ones because CO2 is generated in process. Then this can propagate actually. The spontaneous subsurface fires are not seen. The only can be used for measuring that, or that can be used to assess that as a CO2 concentration. And then this thing, what happens is within landfill itself, it starts migrating from one point to another, or propagating from one point to another as per the characteristics of waste at that particular location, or that particular waste bucket. So limited studies are done in understanding these characteristics or mechanisms of this spontaneous fires. So what is required is a integrated mechanism for prevention and control of this. So what the literature says is like it tries to bring out the understanding of landfill fire types, occurrences, detection, and most importantly is its extinguishing methods. Then spontaneous ignition and fire propagation, I think very less studies have been conducted on that, and particularly landfills or wastes. Then biological and chemical self-heating of waste, that is also addressed, not addressed completely. So we try to address these things in this study. I just wanted to show you a pic here. This is from the it's a Ghazipur landfill. You can see that they've just put two pipes and this there is a fire. They've just lighted it, and then it just keeps burning. You can see the fire here in both the things. So I just purposefully made this video just to see, we regularly visited this site like for 3 years, and then out of the 3 years, almost for the 2 years, it was like burning. There was no stopping. It means that you can understand how much amount of methane would be there at the bottom of the landfill. This is like close to 70 feet, 80 feet. We are at the top of this landfill. So if you come to landfill fires, you can characterize that as spontaneous, deliberate, and accidental. Spontaneous is the one that happens naturally, because of the, as I said, the fire triangle. When it happens, the required conditions are there. It happens. And deliberate is like, sometimes what these site managers or site people do, they, sometimes they actually ignite the waste in order to reduce the amount of waste. So, because what happens is if there is some problem with site, the municipality always orders to take the waste to the nearby site. So during those kind of periods, what happens is like the whole of the waste of one area is diverted to the other waste, and that particular site would be receiving double, triple the capacity or what was designated to receive by that. At that time, what happens is they don't have that kind of facility to manage it. Obviously, this was happening sometime before, like maybe 5 years, 10 years before, but now they have quite streamlined these kind of things. And then the other one is the accidental thing, where no one is responsible, and because of some say issues, uh, this accidentally happens. But coming to the spontaneous ones, you can characterize that again into subsurface and surface, the ones that were that I was mentioning. Again, the subsurface can be characterized into chemical process. Similarly, surface also. So, like I said, the chemical oxidation process, anaerobic aerobic process, so those kind of processes contribute to this. So now I'll just explain in detail like this. So the formation of surface and subsurface. What happens is like there is MSW. So this MSW means we are talking about Am I audible?
Yes, it is audible.
Okay, okay, okay.
But your
No, I
voice
think
is
there was
too
some
low.
power cut. Yeah.
Okay.
Okay, I'll try to be a little bit louder. Yeah. Thank you, Dr. Nave. Yeah. So when these kind of required things are present, then automatically there is a what to say fire. So if you like little go deep into the details. So what is happening is the waste organic content of the waste has cellulose, hemicellulose, and lignin content. That is what I keep on to. So the waste has these things, and then when it what to say reacts, that is always an exothermic reaction, and then you have methane and CO2 that is getting generated as or liberated as landfill gas. And then because of this, as I told, there is MSW maturation, which leads to generation and then temperature rise and then this. So what I would like to mention here is like the cellulose content that is present in the organic content of the landfill is the one that gets completely degraded in a sense. Content of this gets converted into methane and carbon dioxide, and some of it gets converted into leachate. And hemicellulose means, it, as the name suggests, half of it is cellulose and half non-degradable. So half of it gets completely converted to methane and what is it? Um, carbon dioxide. And rest is lignin content, which is like non-reactive, and then it stays there. So this is what I was mentioning about the exothermic reaction. So if you see the aerobic degradation, this is the cellulose or the glucose C6H12O6, and when it reacts with oxygen, then you have CO2 and water formation or release, and then the heat that is generated because it is an exothermic reaction, there is a negative sign. You can see the amount of heat that is generated, almost 3000 kilojoules per mole. The same thing happens with anaerobic degradation, but the quantity of what is heat generated is little less compared to the aerobic thing. Now coming to chemical oxidation, I was supposing that assuming that there is some kind of iron fillings or iron related stuff there, then that also undergoes oxidation, and that also releases around 1200 kilojoules per mole. So when these kind of the of what to say heat is generated, and then imagine if it is not dissipated properly or not collected properly, then what happens? Obviously, it leads to what to say fires or smoldering. So what literature says is like when we started doing this research, um, there was a person called Shad who initially started characterizing this back in 2009. And then, he told, the, what to say, muffle furnace can be used. So what is this AIT? It's nothing but auto ignition temperature of waste. What he found out is like, it was like close to 267 degrees. And also MSW with 10-20 moisture content by weight had, what to say, moisture content, sorry, higher ignition temperatures. So the average auto ignition temperature in other studies ranges between 200 to 350. So we did a thorough, what to say, literature survey before getting into our research, and then we got an idea. Then we started, doing started this research. So this is the location from where, just to show you, this is like one of the locations. You can see this mountain of garbage here. This is like, the what to say, habitation here, and this is the mountain of waste. So if you take a closer look at this, so this is also happening at the landfill site. This is all the what to say, smoldering that is happening at the landfill site. So what we did is like we measured the pipe is what to say, what I showed, that continuously burning. I just measured temperature there. It was almost 369. This is smoldering happening at a different location with that landfill. You can see the temperature is close to 250 thermal temperature. So you can clearly see here. This is what to say, spontaneous that happened. So we try to do some kind of large scale studies for understanding this. So it's like a combination of that particular landfill, physical, chemical. Should I share again, or is it visible?
Please reshare it.
Okay.
You can share your slide. You can switch off your camera.
Okay. Yeah. Just a second. Is it fine now?
Yes, it is fine. Please go ahead.
Thank you. Thank you. Thank you. Yeah. So some of the objectives were these things. Determination of the ignition content was most important of them all. So when we and we get this, what to say, waste composition, we found out some interesting facts. If you see, this is the fresh waste, just immediate, organic plus soil. The next content is plastic waste. You can see almost 29%. And then, the rest others are like, cloth like material or combustible material, and fractions of other things like, paper, metal, etc. And then we started collecting this 1 month old waste. As per the thing, you can see that, organic content is almost 71. So this is very, very, what to say, intriguing actually, because what happens is there is huge amount of understanding is that there will be huge amount of organic content in the fresh waste. But then if you see the 1 month old waste had the highest, what to say, organic content. And then if you take 1 year old waste, again, the plastic content is like, very high. And then the soil and what to say, organic content is around 55%. Then one more landfill was there, Balswa landfill, where, we tried to analyze this composition. Again, it's some kind of, not consistent trend, but some trend was, I mean, like some pattern was observed. Like, the plastic was around 30. This was like almost constant in like all our samplings. And then the what to say, organic content was around 44. Here also, the 1 month old waste also, the plastic was around 23, and then the organic or soil plus organic was around 30, and rest like, fractions. So 1 year old waste again had 50% of organic, soil plus organic, and then high percentage of plastic. So we collected those samples. We tested the pH values. So you can see like, from where and all we collected the samples. So these and all, so the fresh waste had like, almost pH value of 7.7. 6 month old waste was like, kindly alkaline. And if you take the 1-year-old waste, again, it came back to the, within the range, it was less 7.8. So fresh waste, again, there was a, what to say, the trend was like, little variation was there, but it was like not completely alkaline like that was seen in this WTE plant. WTE is the waste to uh, waste thermal treatment, waste to energy plant. So there was a thermal treatment plant there. So this, the what to say, the pH of this was like, really alkaline. The reasons maybe for this is like, they were like, thermally treating it, and then the ash content that was coming out of it, that was getting mixed into the leachate, or that was forming major chunk of the waste. Then coming to the moisture content, you can see the fresh waste had the highest, followed by the 6-month-old waste. Only thing is there's some variations with respect to different landfills. Like the Balswa had 51%, whereas the Gazipur one had 34%. And then what to say, the 1-year-old waste actually, decreased further. So you can see why this thing is very, very important is like, the 6-month-old waste and what to say, 1-year-old waste. If you see the moisture content, it's not even 6% here in Balswa. And then the 1-year-old waste, obviously, it's like not more than 3. So when you have waste older than 1 year, the moisture content less than what to say, 3, obviously going to be some fires. So I'll take you through that. So we just found out a relation between the moisture content and age of the waste, and then the moisture content reduces, like, it comes down to what to say, less than 3%. And similarly, TVS is a what to say, measure of the organic content. So you can see that, the fresh waste had, had little less, and then 1-year-old surprisingly had, higher, what to say, TVS. Maybe this is because, after degradation, some of the components, fiber like components gets, mixed with that, and there is a slow degradation that is happening there. So coming to again Gazipur, the organic content was like more or less this much, 35, followed by the 1 month and 1-year-old waste. So now the important thing, ash content, you can see the older waste had higher ash contents compared to the fresh ones, obviously, because that would be dry and it wouldn't, it would. Now, ultimate analysis is nothing but, we do the CHN analysis. That is to find out how much of carbon and how much of hydrogen is there. And this actually helps us in what to say, doing a mass balance at the end, like, how much of carbon was there initially and where is it going? Because the carbon is the one that goes into CO2 and also into CH4. So if you see initially the fresh waste had around 22 percentage. In some cases in Balsva it had like close to 40 percentage of waste, the carbon percentage, and in Gazipur also, like, it was like partially degraded thing. So the C is to N ratio is one parameter that is used to what to say, measure the or check the compostability of the waste. So coming to the leachate characteristics, if you see Balswa and Gazipur, actually we took both of the things because there was a huge problematic thing in these two landfills. So temperature was not that great. It was like quite nominal. And the most important thing was the TDS, which was like close to 15,000, and it was like more than 15,000, ppm or mg per liter. And the next thing is like, worrying factor was like COD, which was also very high, and of course the hardness, calcium, and total hardness. Then if you see the heavy metals, barium was found to be high, and there were like, what to say, fractions of, or most of the heavy metals, like, aluminum was found, chromium was there in some content, cobalt was there, um, zinc was there, magnesium was there. So all these things were found in the leachate. Now, determination of the ignition temperature. So this is where the important thing comes up. We took 3 waste, like, fresh waste, partially degraded waste, that is 1-month-old waste, and the what to say, 1-year-old waste. The determination of the ignition temperature for the following waste was also done, like the individual components like paper, textile, rubber, wood, etc. So what we did is like, I'll just tell you the procedure what we followed. Like, the ignition tests were carried out for the landfill waste samples in a muffle furnace. And then the waste samples were kept under oxidative environment to represent the field conditions. Temperature was monitored and recorded using a handheld laser infrared thermometer that I showed you in the picture. And smoldering temperature and ignition temperature was noted. So the smoldering was analyzed when the smoke starts emanating. The smoldering started, it was understood like that. Then if you see the determination of smoldering time of waste component, there's a formula that was used, the time required for smoldering of the waste is like nothing but the initial temperature of the waste component and then the smoldering temperature, that is when the smoke started emanating. And this was the equation used for measuring the ignition temperature. It's the time after the smoldering until the till you see the flame or fire. So this was the experiment that was carried out. If you see, these were the components that was placed. This is synthetic waste, this is fresh waste. So we prepared everything, and then it was placed inside the muffle furnace. And the moment you start these kind of you can see slight uh, uh, gas here that is getting generated. So smoke getting generated. That is the point when this thing started. Smoldering started. Then after that, if you see, then you can see some redness here, and then there is some fire here. So that was recorded, and you can see the temperature here. So the thing is where almost initial weight was like 50 grams. So initial temperature of the waste was 28. Smoldering temperature was almost 125, for the fresh waste. And then ignition was 275. So it was it burned completely. Then 1 month old waste, again, can see the temperature, increase for smoldering and, ignition. So, of course, there's no surprise in this that the ignition temperature reduced by around 20. So if you see the 1 year old waste, there is a significant difference in the ignition temperature, comes down to 200. And similarly for balsa thing, again, if you see, it comes down from 270 to 200, 210. And the smoldering also reduces from 120, 125 to 100. So now coming to the time, you can see this time actually. So time required for waste smoldering after gradual heating is it's 34 minutes. And after that, it almost needs 1 hour. So what we did is in the muffle furnace, we had a continuous temperature rise mechanism for every 5 minutes, 10 minutes. And accordingly, the time was calculated. So if you see the fresh waste, the time was high, and then as the age of the waste gets increased, the time also gets decreased. So it comes down from 40 to 36-year-old. So you can see the 60-month-old waste. It's fresh. I mean, it needs almost only 27 minutes, and the temperature you can see 179. Here it is almost 98. This is what I was mentioning during the summer. If the temperature reaches around 90, 95, it starts smoldering. This is the the picture of the experiments we measured in each and every case in the field and in the muffle furnace as well. So these were the individual components, and we after ignition, we checked that also. So we try to find out a relationship between the ignition temperature and the moisture content. And obviously, as the moisture content increases, the ignition temperature also increases. And similarly, when the ignition temperature decreases, the age of the landfill also increases. Means with the increase in the age of the landfill, the ignition temperature decreases. You can see. Now the most important thing is you can see here the 60-month-old waste. The temperature is around, smoldering temperature is around 98, and then time required is around 23 minutes. So if there is a continuous heat that is being given in the form of sunlight or in the form of heat from the anaerobic and aerobic reactions or from the chemical oxidations, then it only takes half an hour to start the smoldering process. And further, if that thing continues, it doesn't take much time to ignite for the old waste. And you can see the moisture content. Moisture content plays a very huge role in these things. So coming to the individual components, so whatever we saw till now is the the mixed waste. Now, if we did these things with the continuous, individual components also. Say, for example, cardboard, paper, newspaper, magazine leaves, woods, etc. So you can see the smoldering temperatures. It's not that, high. And the time required is more or less, it varies around between 25, 30, 35. It ranges in that, you know, temperature range. So as I told, the major findings from this, particular study was like, MSW fresh with moisture content of 50 to 60 percentage ignites at a very high temperature of around say 260 to 70 degrees, and then the older waste gets ignited at a lesser temperature. And consequently, the older waste, like 60-month-old waste, had higher plastic content, which may be the reason for faster smoldering. Then again, we did another, what to say, experiment to estimate the heat generation and consequent temperature rise. So I'll just take you through this. So the heat release per ton of waste of degradation was, was calculated, and these equations were used where, the delta H is the total heat generated, and then uh, the D indicates the heat generated by the degradation of the component. So I is the carbohydrates, proteins, etc. That is organic content, and this is nothing but the what is the temperature rise is calculated in this equation. Like M is the C is specific heat, and M is the mass, and delta T is a change in temperature. So what the study actually told us is like a very important thing. If you see the organic content and the carbohydrate content, etc., in order to what to say assess this. There is a general understanding that higher, what is a conversion rate. It was not like that. Organic content also has some of the components which doesn't degrade completely, like I showed you there. Hemicellulose. If the hemicellulose content is more, or if the lignin content is more within that organic content, then it doesn't get degraded. So what we have to really look at is the carbohydrate content. So if you see the carbohydrate content here in this case, out of the 54 percentage, 43 percentage is a carbohydrate content. And consequently, you can see the temperature rise per ton of waste. It's like the highest, like at 620 degrees. This was collected, the waste was collected from the Mahalipura landfill in Bangalore. Consequently, we collected from Bandewadi, Ahmedabad, that is in Nagpur, Ahmedabad, Delhi, Kolkata, Arunachal, etc. So if you can see the organic content, you can, this, say for example, this Nagpur waste has very high organic content, but then if you see the carbohydrate content, it's not even half. That's why the temperature rise is not that much. Again, you can see here in the waste from Ahmedabad, it's like 43 percentage, and then the carbohydrate content is only 12 percentage. And likewise, the temperature rise is also very less. So this is how it functions. Actually, what we came to the conclusion is it's not the organic content, but it's the carbohydrate content that leads to the temperature rise, that leads to the heat generated, and that is the one that should be what to say, measured. Because what the practice is now is like people just measure the TVS, that is total voltage solids, that is representative of the organic content, and then they say that this, if this is the organic content, then this will be the amount of what to say, methane that will be generated, or this will be the amount of landfill gas emissions, which is not a correct practice. So that is the findings of the study, like I said. So the other part is monitoring the carbon dioxide level. Why carbon monoxide level? Why this is important is this is a representative or indicator of the subsurface fires that happens, because at the subsurface there is no what to say, availability of oxygen in the full content. Whatever combustion happens, it happens in the absence of what to say, oxygen, or very less amount of oxygen is present. So if you see the concentrations of CO has reached more than 500 ppm, more than 500 ppm. So this is the carbon monoxide monitoring meter. You can see here how we have measured it. So 200 it is showing here. The probe is inserted and it measures the CO, oxygen and CO2 content. So what we found is like CO concentrations above 170 ppm were recorded during the pre-monsoon season. So this test we did it regularly, like the pre-monsoon season, post-monsoon season. Every 3 months we did these tests. Uh, so the concentration was like, less than 50 ppm for the subsurface smoldering. CO2 concentrations up to 20 ppm were recorded during the post-monsoon season, because what happens is, like, post-monsoon there will be a good rainfall, and the water would have percolated and it would have made the waste wet, which actually makes the smoldering process not possible, or it actually inhibits the smoldering process for some time. High concentrations were observed during the pre-monsoon season, that is the peak summer season. Like, the concentrations went up to 1500 ppm, and 1500 ppm people can die for exposure up to 20 minutes or 30 minutes. So this is the what to say sampling that is happening at different places like Delhi, Nagpur, Bangalore. So coming to surface temperature monitoring of different waste components, if you see, components like food waste, paper, cardboard, polythene, cloth, wood, rubber, metal, glass, all these things were separately, taken from the fresh waste and the old waste, and these things were analyzed. If you see the temperature, the temperature of those components collected from the site, the temperatures were recorded at, like, you can see this. The old waste had usually higher temperatures compared to the fresh waste, but then you can see the, temperature. The existing temperature of those components itself was close to 60, and it doesn't take much time to, reach from that 60 to 90 for the smoldering to happen. So the important thing to observe here is, like, during this was observed during June, or the pre-monsoon season. But then the post-monsoon season, you can see, it is not even crossing 40. Even the old waste is not even crossing 40. So that is why moisture plays a very, very important role in this. So what also we also did one another experiment. This is called a thermograph. It actually captures the thermal content of the waste, or thermal temperature of the waste. So you can see the waste, when you see the waste up, it looks like this. But then when you capture it with a thermal camera is nothing but it, sends its IR rays to measure the temperature of the waste up to, 5 to 10 meters of the waste from the surface, and then it averages out and gives you the temperature. So you can see this red spots indicates really high temperature, and the surface, like, here it is all because it is the fresh waste that is being put up at the top, and the temperature is little less, that is like around 36. But then if you see look little deep here, you can see the temperature, it is like, around 71. Again, this is like the pre-monsoon season in Nagpur, Pandewadi landfill. If you see the post-monsoon season, the maximum is like, you cannot see this red spots or reddish what to say areas. Very few reddish areas, pockets, and most of it is like in the green zone, that is like, within 30 degrees. The maximum itself is like 49. So this was just to prove ourselves, like, what is happening in the pre-monsoon, post-monsoon season, what is happening to the different components, and why this thing is happening. So like I said, the temperatures were, measured. So coming to the what to say this landfill surface temperatures, the thermal imaging camera did a very good job in capturing this. It has a what to say a range of minus 20 degrees to 300 degrees. So we even carried out one more test that is called advanced analysis of thermographs. What it gives is, like, it gives an in-depth analysis in order to identify the hotspots. So if there is any thermal anomalies also, that will also be captured. So you can see here, you can see these points where there were some thermal anomalies or some kind of, hotspots that needs to be looked into. It's the same picture that was there, and the same thing that you look at. Again, this is a pre-monsoon season and this is a post-monsoon season. You can see a lot of reddish spots. So this is how it is. A landfill looks like this. It is like this. When you capture that in a thermal camera, this is what it looks like. You can see the, heat pockets, or pockets where the temperature is really, really high. So that is it. And what to say, coming to one more laboratory setup, what we did is, like, we wanted to see how the heat is getting dissipated, or how much of heat is getting generated if there is amount of there is some quantity of waste, and if it is a good conductor of waste, sorry, heat or not. Then we fabricated a setup like this. This is a setup completely insulated within inside, like, it has a glass wool, it has a cement sheet which is like insulated properly, and then there is a what to say, plate that covers or closes it, and current is given from one side in order to heat the waste, and probes are being placed. These are all probe holes for the probes for placing the probes, temperature probes, and then temperature at every point is what to say, recorded. So I'll just take you through this. This is how it is. There was a electrical meter and AC voltage regulator for waste heating and measuring that. So when we had synthetic samples. We had samples collected from Bandewadi. We had samples collected from Bangalore and other places also. So this was made basically, density of the waste was calculated, because you need to know the density, volume of the waste to put the waste into the box, moisture content of the waste, organic content, plastic content, and then from that we calculated this thermal conductivity specific heat. Thermal conductivity is, the capacity of the waste components to conduct the waste or transfer the heat from one place to another, so that, if it stays at one place, then there will be a huge problem, like, fires and all. If it is like regularly what to say, conducting it, then there won't be such conditions. Specific heat is the, of course, by definition, amount of heat required to raise the temperature by 1 degrees of some component per unit. So you see the correlation between specific heat, thermal conductivity, and moisture content and organic content. So first is thermal conductivity, moisture content. It obviously decreases as the moisture content increases. The thermal conductivity decreases. Then specific heat, it increases. So as the moisture content increases, the specific heat, increases. So organic content also, the specific heat increases with organic content. But then the moisture content and organic content, if you see, moisture content and organic content actually are like, in a linear relationship, similar to the specific heat and organic content. So what this says is that, if the moisture content is high, then if the organic content is high, somewhere or the other, the moisture content is also, high. And it is always a linear relationship. So we can, like, come to a conclusion for assessing the what is the quality of the waste or condition of the waste. So this figure, what I'm showing, is published in Waste Management, and it gives a very good idea about the specific heat and thermal conductivity of the waste. So if you see this side, it's a temperature, and this side it's a thermal conductivity, and we have the time. So initially what happens is, like, the blue lines tells you the thermal conductivity and the temperature of the heating plate. So it is being increased continuously, and this is the green line indicates the specific heat. Initially, the conductance is very high. The reason for that is thermal conductivity is very high because there is a lot of moisture content, and then what happens is that the more water that is there, it does the job of conducting the heat. But then as the temperature increases, what happens is that water gets slowly evaporated, and then the specific heat gets increased of the components, and it drastically increases after a particular period of time. This is like within 10-15 minutes. This process is what happens inside the landfill also. When the temperature, like, starts increasing above 70, then what happens is the conductivity decreases. And once the conductivity decreases, then there is no um, transfer of heat or conduction of heat, and that heat is, like, accumulated in one place, which leads to all these processes or activities of moldering and ignition. So this one figure gave a very good indication of what is happening. So like I said, the conclusion, that is what is written here. So to make you more understandable things, make things more understandable. This is, say, for example, the waste, and then, like, we have this sample. So what happens is, like, this is the fresh waste, and when the waste temperature is between 35 and 75 degrees, the thermal conductivity is around 3.6. And then when there is, the moisture escapes when the temperature rises from maybe, above 75, and the thermal conductivity decreases. You can see drastically it decreases from 3.6 to 0.34. And then again, the same thing, when that prolongs, what happens is the waste shrinks, and the voids are all filled, or, the gas in the voids escapes, and that those become hotspots. So during this time, the temperature is above 100, and it's like, in between that phase, that is called the smoldering and the ignition phase. And then when this thing continues, there is a ignition, proper surface or subsurface ignition. The temperature usually is more than 140 degrees, and then the thermal conductivity is less than 0.07. So that is what this figure says. So as the thermal conductivity decreases below this point, there is every chance of what to say, smoldering and ignition. So then after this, we had this curiosity in order to find out what is the.
Lakshmikanth, sorry to
Yeah,
disturb you.
no
Yeah,
problem. Please tell me, sir.
yeah. Could you please wind up because let
Yeah,
them give because 6:30 they have exam.
no problem, no problem. I'll do it.
So
Done, done, done. Yeah,
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 it
yeah,
can
yeah.
take
Yeah.
maximum 5 minutes. So
I think yeah. Though I think I'll run through the slides. That's
yeah, yeah,
fine.
yeah.
Thank you, Dr. Naveen.
Yeah, because let them give 15 minutes for the revision. So
Okay, okay, yeah. They also must be tired after the long,
yes, yes, they are
days,
sitting from
hectic
2
schedule.
p.m.
Fine, fine, fine. No
Immediately
issue. So
then,
I'll wrap up with this particular thing.
yeah, after 5 minutes, let them take some if they have any clarification.
Yeah, yeah, yeah. They
Then
let them ask.
yes, yes, yes.
Yes, yes, yes. Okay,
Okay,
okay.
sir, please.
Okay, thank you, doctor. So this was like one more experiment where we did like in order to find out the what to say lignocellulose biomass content. So we did this experiments. We monitored all these things. So you can see the graphs here. Like this particular thing is like the what to say synthetic waste, fresh waste, 3-month-old waste, 6-month-old waste, etc. The thing is like there is a landfill gas generation. That is what is the message to take away. And then the fresh waste is like giving more gas, and then the compared to the older waste. Again, the combinations and their correlations with the age and the cumulative production. So one more thing is like effect of leachate recirculation on this spontaneous ignition. So when there is ignition and when there is what to say leachate circulation, what happens to the waste? This was done because most of the suggestions is like go for cost effective techniques like circulate the water or leachate, etc., etc. So we just did this thing. So what happens after that? So you can see this. The leachate, when there is a fire, we purposely ignited a fire and then started recirculating leachate. So before ignition, you can see the conductance TDS, and then after 24 hours, there is not much difference. So we can this says that we can safely what to say recirculate leachate. Similarly, you can see the BPH, biological BOD, COD, and also that also there is not much increase before and after. The only thing is like during the 24 hours there is a significant variation, so that needs to be carefully dealt with. Again, coming to the parameters like heavy metals and all those things, again those things are here. So you can see there is not any significant increase in most of the heavy metals that are like very very harmful like arsenic or chromium, etc. They are like in the similar range. So yeah, findings of the study, and I think I will conclude here. The major takeaways here, okay, takeaways are that we saw the causes of landfill fires. We saw what can be done. So through this experiment, what we concluded is like the quantity of leachate required for extinguishing 1 meter cube of waste or waste fire is around 40 to 80 liters. So that's the amount of what to say a leachate or water that is required. And second thing is like if the moisture content is maintained at 25-30 degrees, I don't think so there'll be any what to say chance of fire. So usually what happens is like what we had suggested is like during the peak summer season, just keep recirculating the leachate or water every week so that the temperature doesn't go above 70. That was a major thing that we suggested to the. This was a major project from DST, and we gave some really insightful conclusions. And why I chose this thing is like there is a huge amount of waste that is lying that can be used, and this waste to innovation thing, there are a lot of things that can be utilized. Waste can be utilized. Already it is being used up as RDF, as compost reject, as compost, etc. So we can like further try to go a little further and then innovate different ways how this waste components can be used, and then it can be reduced, because we cannot stop the generation of waste. Of course, we can find out new methods to what to say tackle with this waste. So with this, I conclude my talk. If there are any questions, please.
Sir, good evening, sir.
Yeah, good evening. Please tell me.
Sir, this is Dr. Jayapal from NIT Jamshedpur.
Okay.
I'm basically a geotechnical engineer. So,
Okay, great.
I'm. I have a question in my mind. It's like, what happens to the leachate after it gets collected from the landfill? It's like that is the final product that comes out of all the waste. That's the black color liquid that comes out. After collecting that, what happens to it? How do we treat it? How do we dispose it? Or what happens to it finally?
I'm sorry, I'm sorry, Dr. Jaipal. I just lost you. Can you just repeat the question?
Sir, the final end
What
product that
happens
we
to
get,
the what
what
happens to the
happens to the
leachate?
leachate finally? Are we treating it again, or are we disposing
See
it?
what
Or
I'll tell you what happens in the landfill at present. What they do is like they have a pond kind of thing, solar pond that is called. So they will like leave the leachate there for evaporation. That is a
okay,
most preferred method because there is no cost involved in that.
okay,
Whatever leachate, extra leachate gets connected, they just store it. What happens because during monsoon there is a huge amount of leachate that gets collected
okay,
generated, collected. So what they do is like they store it. Some of the leachate, the concentrated, there is a leachate also. They actually what to say, divide it as a young landfills leachate and a old landfills leachate. So the old
okay.
landfills leachate is like not that what to say harmful as the
Toxic.
yeah, toxic or the as the young landfills leachate is there. And sometimes this you can't like just exactly say like that. Sometimes the young landfill leachate is concentrated, sometimes the old landfill leachate is concentrated. So what they do is like they have some amount of
Okay,
leachate for recirculation. And then what they do is like if the TDS goes above some particular number, say 25,000, 35,000, what they do is like they send it to the solar pond. There it evaporates.
o-
Some
okay,
places what they do is like they send it with the this effluent treatment plants will be closer in an industrial setup, industrial areas. So what they do is like they will not mix it with the sewage treatment plants, but then they will send it to as a as a dilution to the what to say effluent treatment plants, industrial effluent treatment plants, because the effluents from the industries that comes is very concentrated compared to this.
okay. Sir,
Yeah, that
can you
is
share
what
your slides once more?
which one?
Sir, I was so particular about. There was one slide that
Yeah, yeah.
was showing about
Ah,
the unit of the temperature.
one second. I'll just go there. You can one second. If it is getting open.
So this is my last question, sir. I'll not bother much. Why? Because
Oh,
the
no,
other
no, no, no,
participants are
please.
waiting.
Absolutely no issues. I am just opening it just a second. Yeah, is it visible now?
No, 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 it is not. There was one.
Okay.
No, no.
I
Can
think I
just go through.
shared it.
It was like joules per g dot k. J is joule bar g dot k. K is Kelvin. Giga Kelvin.
Is it okay now? Can you see it?
Yes, 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 yes. I can see, sir.
Yeah,
I can
please,
see.
please stop me. Which slide I should
Yes,
stop?
it was a graph. The last final
Okay,
graph.
okay, last graph. The
Mm,
yeah, I got it. What you're talking about. I go to that particular graph. One second, just give me a time. Yeah,
yeah,
this
this
one.
one, this one, this one. Yeah,
Okay,
in terms of joules per giga Kelvin, right?
gram that
Giga
is.
Kelvin,
No, no, no,
gram
no. That
Kelvin,
is not giga. That is per gram Kelvin.
joules per gram,
Yeah.
and dot K is Kelvin. What?
See, yeah, Kelvin is like, because joules is like, so much joules per gram, that is per unit of MSW or whatever it is. And then Kelvin is a temperature.
Okay. It should.
Yeah,
How should I read it? How should I read it? It should be joules.
joules per gram. Like, it's the temperature rise per
Okay,
joules
okay,
per
okay.
gram. Yeah, or
If you
the,
see towards the
yeah,
right, there is one more thing that is written as joules per
this
m
one.
dot s dot k
Yeah,
and specific heat,
this is conductivity, no? This is specific
thermal
heat.
conductivity.
So if you,
Okay,
yeah, yeah, this is like as per the definition, the specific heat is like amount of the temperature rise to required to raise the what to say temperature of unit this thing by uh, uh, unit area or unit weight by the as per the definition, that is what is given here. And thermal
Okay, okay.
conductivity is, yeah, this is the conductivity, so many, what to say, Kelvin per meter, per second. That is what it is. Like, the temperature, whatever we are giving per, you saw the setup, right? Thermal setup.
Yes, 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 yes.
Yeah, here what we do is like we try to give some, what to say, heat, and that is
Okay,
like,
okay.
calculated per, joules, because this is not a AC, this is a DC.
Okay, direct current. Okay.
Yeah, so this is a direct current setup, and then there it measures like this, and then what we do is like we convert it finally like that.
Okay, 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 sir. Thank you,
Yeah.
thank you.
Hope that things are clear. This paper is also there in waste management, and one has gone into science of total environment. So you can,
Sure, sir, sure, sir.
I mean,
Thank you,
like
thank
if
you so
if
much. It was
if
a nice.
needed, then I can share it with Dr. Nabil,
Sure, sir,
and
sure,
then
sir.
you can
It was a
collect it from
wonderful
him.
lecture.
Yeah.
Yes, sir. Please, please, please. Thank you so
Thank
much.
you so much. Thank you. So any other questions?
Sir, good evening, sir.
Yeah, good evening. Please
Sir,
tell me.
this is my Shankar from NHC. Sir,
Okay.
actually, you are mentioning that on table that series of six case studies in that estimation of heat generation and the consequent temperature rise. In that table, you are mentioning about the mass in grams, that is municipal solid waste mass in grams in that table. That is
Okay.
a waste generation the rate of average waste generation rate or daily waste generation rate or maximum waste generation in that cycle. Because you are mentioning mass in grams, that mass means mass of municipal solid waste. So that waste you are mentioning some six case studies you are mentioning the waste quantity.
Correct.
That is which is the average waste generation rate or maximum waste generation or daily generation rate. I'm asking
Okay.
about that because
Can you tell me which table actually? Heat
that
generation and consequent
table,
temperature rise? Different case studies. That one.
yeah, different case studies. That one, that
Okay.
table only.
Okay. 1 second. I'll just share it so that I can explain you better.
Sure, sure, please.
Yeah. So is it the one that you're talking about? Can you see
Yes,
the
sir.
slide?
Yes,
Okay,
sir,
sir.
yes, sir, I can see.
Yeah. Yeah. What
In
is that you want to know in this?
that quantity of waste in tons you are mentioning.
Yeah.
Yeah, this tons means that this is the average waste generation or maximum or daily, which
No,
I have to take.
this is daily. This is daily actually. That particular
Okay.
landfill
Uh,
receives this much of fresh waste per day.
per day.
Yeah.
Okay. Okay.
So what we do is like here,
Uh,
we
yes, sir.
employ people. So there are like,
Uh,
almost 32, what to say, what is that? Lorries, or what they call is like,
this is, yeah,
trucks.
I can
Yeah.
understand. Uh,
Trucks that comes. So what happens is morning 32, like, they keep coming. So what
okay.
we employed our students to measure the moisture content of each and every lorry that comes, and like at least 6 or 7 samples from each and every lorry. So like,
Okay.
what happens is like per day, what happens, whatever comes, then that
Uh,
thing, we measure that, and the average is put here, not just like, one thing. So this
okay.
the thing was repeated, like, for say at least 1 week.
1 week. Okay, so
So
because
yeah, 1 week.
we have a waste generation rate, the daily waste generation rate we have. So it is somewhat varies not in the same number. That's why I'm asking the question. This is.
Yeah, that is what I'm telling. So here what
Uh,
happens is like it'll be little this side, that side. So average is like around this much.
okay, sir.
Yeah. So, sometimes it may be 1,550 or 1,600. Some days it may be 1,400. But then what we are taking is the average here. Similarly, the moisture content also.
Okay,
Yeah.
okay, sir.
Yeah. Any other questions?
No, sir. Sir,
Okay. Okay.
another question. So you are taking that carbohydrate, the fats and proteins only. So what about the inert materials, sir? Because they are also contribute the heat generation in the term site. But
No,
in uh,
inert materials don't contribute to the heat generation. what happens is inert materials are some kind of what to say insulators only.
Sir,
They don't conduct.
that is no, sir. That is iron and aluminum materials that are creation pyrolysis happen inside the dump site. Maybe that anaerobic environment. So there is also
Okay.
some heat contribution. That's why I'm asking, sir.
No. Here inert means what happens is like inert means proper inerts. Like materials
Okay.
like glass will be there. Materials like earth will be there. Earth in the sense soil. So that is what is
Okay.
termed as inerts here,
Okay.
which don't undergo biodegradation in any form. So what
Okay.
happens is like we consider here as like glass, metals, and what to say metals also separately it is categorized as metals, but then mostly it is
Mm.
soil and glass. So you can see the sand like particles. Those are the inerts.
Okay.
That doesn't contribute to any kind of heat propagation or heat this thing. Only it contributes to the it acts as an insulator. It just traps heat. Traps in the sense it just insulates that particular pocket wherever it is.
Okay, sir. Okay, sir. Now I can understand.
Yeah.
Okay.
Thank you.
Okay.
Yeah, thank you, Mail
Thank
Shankar.
you.
Yeah,
Thank you,
thank you.
sir.
Yeah, any other questions, please?
Sir, I have one question.
Please tell me.
Yeah, you were showing that heavy metals also present in that, like
Yeah,
aluminum, barium, cadmium, and all.
yeah,
Whether it
yeah,
is
yeah.
possible to recover that? Whether you have tried that?
No, actually, what happens is you might have seen the quantity. It is very, very less.
No, I had seen the quantity. Barium, you had mentioned around 1,000 or 600 ppm, milligram per liter. You
Yeah,
were mentioning that, right?
correct.
I am asking about only that barium. Other metals are traces only. It is not possible. In a liter itself, it is around 500, 600 milligram means tons and tons of waste. We can recover that, right?
To be very frank, the recovery process of these heavy metals is not that simple. And then, since,
Yeah.
so many metals, you can see almost 20 elements or 20 heavy metals there, sitting as a, sitting in a, what to say, kind of, collegium. And it is very difficult to separate one from that kind of setup. And, as of now,
Okay.
to my understanding, it's very difficult to, invest that amount of energy, money, and time for recovering that.
Okay.
Yeah.
Okay.
So this actually
Okay.
some
Then.
people have tried it, but it is not possible.
Okay.
Yeah.
Okay. Then. Thank you.
Yeah. Yeah. Yeah.
Thank
Any
you,
other questions?
Lakshmikanth. Thanks a lot.
Okay. Yeah.
Yeah, I request participant, please log in your Atal portal and take the exam. No links will be provided in your Zoom or in email ID. Every participant should log in their respective login ID and take your exams. It is only duration is only for 1 hour.
Sir, some more login issue is there, sir.
Because everyone are logging multiple
Yes.
times, means simultaneously, na?
Yes, sir.
Even I
Yes,
had a word with backend team also, ACT Atal concerned people. They told everything is fine because almost 200 participants logging same time. That's why you can refresh and you can log in. It will be done.
So, sir,
Okay.
what if
Okay,
if
sir.
we are, sir, if we are not able to
Little
log
more
in? So,
time.
I didn't get.
Sir,
Yes.
loading.
So my attendance is not updated. That's why there is no any option
No.
to
It's a
access the
wrong. It's a
assessment.
wrong assumption. It's a wrong assumption. I have clarified with ACT Atal people. You please don't bring attendance concept here. It will be
No,
done
but there is
simultaneously.
no any option to attend the assessment. When I
No.
click
Link
assessment,
will be
You have to log in.
visible after only 6:30. Now maybe it will be
Yes.
available.
See, now at 6:30 it
Sir,
became.
attendance it was not updated, sir.
You please don't worry. We have shared.
It is showing only on December 2nd.
No. Same attendance sheet. We have modified the date. The same attendance sheet will be there for different date. I request you, instead of discussing, please take your exam. After exam, we will have a discussion. No need to worry.
okay, sir.
6:30 to
Thank
7:30
you.
is your precious time.
Thank you,
Request
sir.
all participants, don't waste your energy or time for discussing attendance. You please take your exam. That is very important. Okay.
Hello, sir. We are not able to log in on Atal portal.
Sir, simultaneously all participants are logging at a time, na? That's why the load will be
It's
there.
saying,
You have to refresh and you have to try.
Sir, our time is wasting now, sir.
Sir, how I can see whatever the guidelines they have issued, I'm following, sir. You please understand
Okay.
my constraint also.
Okay, sir. Okay, sir.
And they told me to conduct through Atal portal only. That's why I done. Even I prepared a Google link also. They told me you should be done there. So after submitting immediately, you will come to know your marks, everything immediately. So that
Okay,
is the
sir.
reason. And that will be valid to issue your certificate, they told me. So I'm following, I'm trying to help you out. Please cooperate with me.
Okay, sir.
Okay, please.
It's not getting logged in.
Sir, you can sign out from here. You can,
We can leave the meeting.
yes, you can leave the meeting.
Okay, sir. Then leaving the meeting and trying because the same problem is happening.
Yeah, again 7:30 we will meet for validatory function. 7:30
Okay,
is the validatory
okay, sir.
function. We will meet. You can
Thank you.
log out and you can take your exam.